Hello Algebra 1 students, this is lesson 55. Our objective is, how do you solve a system of linear equations by graphing? Well, there's lots of words in there. First of all, a system of equations is just a set of equations. When we're talking about linear equations, we're talking particularly about lines. So we're talking about a set of lines. And then we're solving them, which means we're going to try to find their solution. Now remember, a line is just an infinite number of points that are so close together that they form a line. And so when we're talking about more than one line, we're talking about where those two lines cross, and a solution to a system of linear equations is the single point, or more than one point, if any, that they have in common. So a point that's on both lines. And there's more than one way to solve system of equations. And for me, maybe one of the easiest ways is by graphing. So we're going to start off with graphing. We'll learn about other ways, substitution, elimination, matrices, things like that later on. But today we're going to solve them simply by graphing. There is some limitations to that, but it will work pretty well for today. So let's just talk about how we could, different kinds of solutions. Here it said point or points, and then if any. So it's kind of, notice there's three different things. So we can end up with just one particular solution, which would be a point, right? My answer in this case would be like x comma y, right, with numbers in there for x and y. Or it's possible to end up with no solutions, or it's possible to end up with infinitely many solutions, an infinite number of solutions. So first of all, let's talk about the most common one, and that's just where you have one solution. And so it's like you have a line that goes this way, and maybe you have a line that goes this way, and it looks like they cross at some point. It may or may not be on an axis, but that point right there is like an x comma y, and that's the point that's on both lines, so that's a solution. And you can kind of identify that by looking at those lines and realizing that they have different slopes. If lines have different slopes, then they will intersect at some point. The next option would be lines that do not intersect. So those would be lines that are parallel. So if we have a line like this and a line like this, those are parallel lines, and they will never touch each other. Therefore, they won't have a point in common. So those we would say no solution. And on lines that are parallel, they have the same slope. But they have different y-intercepts. Notice this one crosses up here at a positive number, this one crosses at a negative number. They could both cross at a positive number, but just have to be a different positive number. Okay? And then the last option, I'm going to use two different colors for here. The last option would be if we have a line, say like this, and then we have a line, say like this, that goes exactly right on top of it. These are lines we call coinciding. And really they're just two lines that have the exact same equation. They're two lines that are the same line. And those ones will have the exact same slope, kind of like these ones do here, but these ones will also have the same y-intercept. So essentially these two will have the exact same equation, at least in core they'll be the same. They might look slightly different, but if you worked with them, you could get them to look exactly the same. Alright, so enough talking, let's see about finding some solutions here. So I'm going to graph these here. Notice this one here, the slope is 1 over 1. This one is 2 over 1. So I'm going to graph this first one up here in red. It has a y-intercept of 3. I'm going to go up 1 over 1 several times, and I'm getting these points. I can go down 1, left 1. And it's going to form this line right here. The second line I'm going to graph in blue. This one has an intercept at 1, and it goes up 2 over 1, up 2 over 1. or down 2 left 1. So it'd be the line that looks like this. Now whenever you are working on your homework, you will use a straight edge of some kind, like maybe a ruler or an index card or something like that, so your lines look nicer than mine. But the answer is not just graphing these, the answer is finding the point they have in common. Notice they cross right here at this one point right there. I didn't draw it very good, but that is the point where the x is 2 and the y is 5. And that is my answer. And if you plugged this point into either one of these equations, they would come out to be true. They're going to be true. Okay. Example 2. I'm going to graph this first one here in red. Has a y-intercept of 3. Slope of negative 2 is going to go down 2, right 1. Down 2, right 1. Or up 2, left 1. So it's going to look like this. Okay. Now let's see about graphing the second one. This is in standard form almost, so I'm going to try to get this into y-intercept form. So I'm going to subtract 4x from both sides. So I'll end up with 2y is equal to negative 4x plus 6 divided by 2. Y is equal to negative 2x plus 3. So, across the y-intercept at 3 comes down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. So notice what's happening is that this blue line is going to end up graphed exactly on top of the red line that I already graphed. And you'll also notice that this equation here looks exactly the same as that one. And so this is a case that we don't just have one point in common, all these points are in common. And so my answer is going to be infinite number of solutions. Alright, let's try another one here. Again, the top one here is going to be in red. I'm going to subtract 3x from both sides, which is going to give me y is equal to negative 3x plus 9. And this is going to be a little bit complicated to graph on my graph because it doesn't go up that high. So this is 7, so 8, 9. And then I'm going to come down 3, so 7, 8, 9, right 1. Down 3, 1, 2, 3, right 1. We're getting the idea. 1, 2, 3, right 1. So again, you can use a straight edge. Yours is going to look nicer. Mine's going to be this next one. I'm going to do this blue one. Subtract x from both sides. 2y is equal to negative x plus 8. Divide both sides by 2, and I end up with y is equal to negative 1/2 x plus 4. So I'm going to come down 1, right 2. Down 1, right 2. Down 1, right 2. Up 1, left 2 maybe. And now I have this line. So again, just because I graphed it does not mean that I have an answer. The answer is right here that they have in common. They have the point 2, 3 in common. So that's going to be my solution to both of these equations. If I plug this into that equation, they both come out to be true. Alright, let's do this next one. Again, the first one in red. Crossing at 2, down 1, right 3. Up 1, left 3. Graph that. The next one I'm going to have to work with just a little bit here. So this is in blue. Subtract x from both sides. 3y is equal to negative x minus 3. Divide both sides by 3. Y is equal to negative 1/3 x minus 1. So there's a negative 1. I'm going to come down 1, right 3. Down 1, right 3. Up 1, left 3. Up 1, left 3. And graph this line. And what do you notice about these? They for sure don't graph. They for sure don't cross on my picture. And then if you look, this one has a slope of negative 1/3, and this one has a slope of negative 1/3. Notice their y-intercepts are different. So since their slope is negative 1/3, that means they are going to be parallel. Since they're different y-intercepts, that means they will never cross. So that means this one has no solutions. Alright, your homework is a worksheet there. If you haven't picked it up, go do that and get to work. Good luck.